Hi everyone, today we are going to discuss previous CBSE board examination questions given in 2024 March stream from one of the most important chapters of calculus, that is integrals chapter 7. And we all know about integrals that it is one of the toughest topics of calculus, and it's a vast topic because it contains almost 11 to 12 exercises even in revised CBSE syllabus also. But according to me, if you are familiar, comfortable with differentiation, it is very easy to understand and answer calculus, especially integrals problems. Let's first of all understand what is the weightage of this particular topic in coming CBSE board examination. So the weightage is going to be, see, there is a one, this is actually this something that you can see on the screen, given in 6511. This is code of this board examination paper 2024 March stream, and there is one MCQ given as well as one 2 marks question given, and then come to this is one 2 marks question, and in 2 marks question there is an internal choice also, and there is one 3 marks question also given, right? So one mark question, 1 mark, 2 marks question, and that is one question, right? 1 plus 2 3, 3 plus 3 6, and there is one 5 marks question also given. See, this is a 5 marks question. So 6 plus 5 is equal to 11. Those who are trying to score 100 on 100, you must have to be focused on integrals compulsorily. Okay, without any delay, let us get into our topic and let's discuss these questions. Alright, now coming to the very first question given, and everybody knows that this is one simple question because it's a property of definite integrals. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x into dx, right? It's a direct question, everybody knows this. And coming to the second one, see, there is an internal choice, so that we are going to discuss about this internal choice question. Now coming to first part of the question. In this first part, integral x root over 1 plus 2x into dx. So whenever you come across this kind of questions, see, x times root over 1 plus 2x, right? So this 1 plus 2x is equal to some t square. It should be a square number because square and root gets cancelled. So 1 plus 2x is equal to t square. Then what is the derivative of this? Because you need to find dx also now. So differentiate this with respect to x. One derivative is 0 as it is a constant, plus 2 into x derivative is 1 is equal to t square derivative is 2t, and t derivative is dt by dx as it is with respect to x. So finally, what is dx here? See, this is 2 is equal to 2t into dt by dx. So 2 and 2 gets cancelled. Therefore, dx is equal to t into dt. Alright. So dx equal to t dt. When you substitute that here, it is going to be integral x. X is nothing but 1 plus 2x is equal to t square. From that, 2x is equal to t square minus 1, and x is equal to t square minus 1 by 2. I am going to write that t square minus 1 divided by 2 into root over 1 plus 2x is equal to root over t square is going to be t, right? And what is dt? Dx is equal to t dt into t dt. Hope you understand this. That implies you can take 1 by 2 outside. Integral t square minus 1 into t square. T square into t square is t to the power of 4 minus 1 into t square is equal to t square into dt. So finally, it is going to be 1 by 2 into integral t to the power of 4 is going to be t to the power of 5 by 5 minus integral t square is t cube divided by 3. Please do not forget writing constant plus c. That implies this is going to be 1 by 2 into t power 5, 1 by 2 into what is t power 5 by 5. See, 1 plus 2x is equal to t square, right? So t is equal to 1 plus 2x whole power 1 by 2. So t is 1 plus 2x whole power 1 by 2 whole power 5 is 5 by 2. So you can write it as 1 plus 2x whole to the power of 5 by 2 divided by 5. Similarly, 1 plus 2x whole to the power of 1 by 2 whole cube is nothing but 3 by 2 whole divided by 3 plus c. So this way you can answer the problem easily. Alright. So coming to the next problem. What is the next problem given here? Integral 0 to pi square by 4 sine root x divided by x. So pi square sine root x divided by x is nothing but, when you answer this particular problem, see 1 by root x is there now. What is 1 by root x? Is the derivative of root x. Like root x derivative is 1 by 2 root x. So 1 by root x is a part of derivative of root x. So I am going to answer this problem as integral 0 to pi square divided by 4. See, pi square divided by 4 is completely a square number. So how are we going to use this square number? Let's make it out. Into dx is the problem. Now I am going to take root x is equal to t. When root x is equal to t, 1 by 2 root x dx is equal to dt. When 1 by 2 root x dx equal to dt, we know 1 by root x dx is equal to 2 times dt. Alright, so dx by root x is equal to 2 times dt. But as it is having limits, simultaneously you have to change the limits also. How are you going to change the limits? Now see, root x is equal to t, right? X is equal to 0 as well as x is equal to pi square by 4. So when x is equal to 0, then t is equal to what? Root over 0. Obviously it is 0. This is the lower limit, and upper limit is x is equal to pi square by 4 means what? Pi by 2 whole square only, right? Then what is the value of t? T is equal to root over pi by 2 whole square. Root over pi by 2 whole square is going to be pi by 2. Therefore, our new limits are from 0 to pi by 2. Therefore, integral 0 to pi by 2, right? Sine root x is nothing but sine root x is equal to what? Root x is equal to t into dx by root x. What is dx by root x? 2 dt into 2 dt. So finally it is going to be 2 into integral 0 to pi by 2 sine t dt. What is integral of sine t? Is minus cos t, right? So which is going to be minus cos t between the limits 0 to pi by 2. So what am I going to do here is, this is minus, right? I leave this minus outside. So minus 2, now I am going to apply the limits. That is cos t, t is nothing but pi by 2 minus cos 0, which is going to be minus 2 times cos pi by 2 is cos 90 is going to be 0 minus cos 0 is going to be 1, which is minus 2 into minus 1 is equal to plus 2. So this way easily we can answer the problems. These are worth of 2 marks questions. And coming to 3 marks question. Once you have a look about these 3 marks questions, there are particularly two questions given: x square by x square plus 4 into x square plus 9, and one is on the limits, right? Integral 1, 2, 3. This is a different integral question. Coming to the first part of the question. What is first part of the question given here? Integral x square divided by x square plus 4 into x square plus 9. X square plus 4 and x square plus 9. See, this kind of questions can be answered, can be divided using partial fractions easily. But one more important thing here is, whenever you come across this kind of question like x divided by x square plus 4, x divided by x plus 4 into x plus 9. See, here it is x square, this is also x square, right? So then what are you supposed to do? 1 divided by the difference. What is the difference between 4 and 9? 9 minus 4, obviously that is 5, times x square plus 9 is obviously greater than x square plus 4, right? So 9 divided by x square plus 9 minus 4 divided by x square plus 4 into dx. Please do follow this so that you get the answer easily. Alright, that implies 1 divided by 9 minus 4 is equal to 5, right? So 1 divided by 5 into integral 9 divided by x square by 9. So 9 divided by x square plus 9 into dx minus integral 4 divided by x square plus 4 into dx, right? So then this is in which form? 1 divided by 5 into 9 integral dx divided by x square plus 9 can be written as 3 square. Similarly, minus integral dx divided by x square plus 4 can be written as x square plus 2 square. So both of them are in which form? Dx by x square plus a square. Here also dx by x square plus a square. What is the formula for dx by x square plus a square? Yes, 1 by a tan inverse x by a. So 1 by 5 is outside. 9 into, for the first fraction, 1 by a tan inverse x by a. X by a is nothing but x by 3. Minus 4 into, here it is 1 by a means 1 by 2 into tan inverse x by a is x by 2. So finally 1 divided by 5 times 3 ones and 3 threes are 9. So this is going to be 3 tan inverse x by 3 minus 4 and 2 can be cancelled 2 times. So 2 tan inverse x by 2 plus c. See, this way you can answer the problem easily. Right? This is a worth of 3 marks and it can be answered easily by using partial fractions. Coming to second part of the problem. What is second part of the problem? See, here it is integral 1 to 3. Right? So integral 1 to 3 f of x into dx. Right? I am going to change the pen now. Alright. Now second part of the problem is integral. This is part B. Integral 1 to 3 modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3 into dx. See, whenever you come across these kind of problems, you do one thing. X minus 1. Only one formula that can be used. Modulus of x is equal to positive x when x less than 0. When x greater than 0. Right? This is x greater than 0. As well as is equal to or x greater than equal to 0. No issues. Is equal to minus x when x less than 0. Right? So it is x minus 1, modulus of x minus 1, I will just give a clarity, modulus of x minus 1 is equal to plus x minus 1 when x minus 1 greater than or equal to 0, is equal to minus of x minus 1 when x minus 1 less than 0, right. So x minus 1 greater than or equal to 0 means x greater than 1 or greater than or equal to 1, here x less than 1. So with this we can understand one thing, that when x is less than 1 then only this x minus 1 become minus of x minus 1. But here limit is starting from 1 onwards, right. So when it is starting from 1 onwards means it should be x is already greater than 1. When x minus 1 is greater than 0 means x greater than 1, above this always x minus 1 is positive. X minus 1 is positive. Similarly, what about x minus 2? It is more than 1 in the sense it can be less than 2 also. Now you are going to change the limit. So when you are going to change the limit from 1 to 3, first 1 to 2 and then 2 to 3. Alright, because x minus 1 is there, right? So here at x minus 1 we are going to change the limit. So in order to change the limit, I am just going to change the pace. Something can be deleted from this. So when you delete this particular part, alright, so we are almost there. Now you all understand what about the limits and how the limits can be changed in this particular situation. So limits can be changed as per the situation, saying that, now see, now here it is, this is x minus 1, x plus 2, x minus 2, x minus 3, right. So what about the limits now? Integral 1 to 2, integral 1 to 2, modulus of x minus 1 will become positive x minus 1. 1 to 2 is nothing but less than 2 only, no? Less than 2 means x minus 2 become what? 2 minus x. So plus 2 minus x, and then plus x minus 3 less than 3. 1 to 2 means less than 3 only, no? Again x minus 3 will become 3 minus x. Okay, so this is about the limits between 1 to 2 into dx. Next, what about the limits from integral 2 to 3? Integral 2 to 3, modulus of x minus 1 already more than 1 this is, so x minus 1 become x minus 1 only. And then what about x minus 2? It is more than 2, so x minus 2 become x minus 2. But it is less than 3, right? Since it is less than 3, x minus 3 become 3 minus x. Alright, 3 minus x into dx. Now you are going to simplify this. So when you simplify, once you observe, I think there is some cancellation possible here. That cancellation is integral 1 to 2 x minus 1 plus 2 minus x plus 3 minus x into dx plus integral 2 to 3, this is x minus 1 plus x minus 2 plus 3 minus x into dx, right? So here plus x and minus x gets cancelled, and after that it is 1 to 2, 2 minus 1 is equal to 1, 1 plus 3 is equal to 4 minus x into dx plus integral 2 to 3, what is the cancellation here? Again plus x and minus x gets cancelled, and after that minus 1 minus 2 minus 3 plus 3 gets cancelled, and then x dx. So finally integral 4 is nothing but 4x, integral x is x square by 2, but here the limits are going to be 1 to 2. Similarly integral x is equal to x square by 2 between the limits 2 to 3, right? So when you apply the limits here, when you apply 2 here, 4 times 2 is equal to 8 minus 2 square equal to 4, 4 by 2 is equal to 2. This is about the upper limit, minus what is the lower limit? You substitute 1. 4 ones are 4 minus 1 by 2. This is about first part, plus coming to the second part. Here it is, when you substitute, this is x square by 2 between the limits 3 to 2, right? When you substitute 3, 3 square is equal to 9 divided by 2 minus 2 square is equal to 4, 4 divided by 2 is 2. Finally, what do you get? 8 minus 2 is equal to 6 minus 4, minus of minus plus 1 by 2, and here plus 9 by 2 minus 2. See, 6 minus 4 is 2, 2 minus 2 gets cancelled, right? 1 by 2 plus 9 by 2 is 10 by 2, 10 by 2 is going to be 5. So this way you can answer the problem. Alright, so moving on to the next problem. So what is the next problem given here? This is a 5 marks problem. Integral 0 to pi by 4 sin x plus cos x divided by 9 plus 16 sin 2x into dx. This is one of the most important problems come across in almost every single board examination. Whenever you answer these kind of problems, see sin 2x, sin x plus cos x. So what is the relation between sin 2x and sin x plus cos x? And the sin x plus cos x dx is there in the numerator. Sin x plus cos x is the derivative of which function? Sin x plus cos x is the derivative of which function? So my function is going to be, you can easily identify, sin x is the derivative of cos x is the derivative of minus sin x, isn't it? So I am going to take sin x minus cos x is equal to t. If sin x minus cos x is equal to t, then derivative of sin x is going to be cos x minus derivative of cos x is minus sin x. So minus of minus is plus sin x into dx is equal to dt. That is right there in the numerator now. So instead of numerator we can write dt. But where do we substitute sin x minus cos x equal to t, or how do we utilize that in order to find sin 2x? That is one of the important concept now. And this is only the substitution. Listen everybody, this is the substitution can be used In every single problem, whenever you come across sin x plus cos x is there in the numerator and sin x minus cos x, otherwise sin 2x terms are there in the denominator. Alright? Okay. Now, how do we identify sin 2x from this sin x minus cos x equal to t? I am going to square it on both the sides. What is t square? Sin x minus cos x whole square. Sin x minus cos x whole square is in the form of a minus b whole square. A square plus b square minus 2ab. A square is sin square x plus b square is cos square x. So, sin square x plus cos square x is 1 minus 2ab, 2 into sin x into cos x. What is 2 sin x into cos x? Yes, it is sin 2x. So, t square is equal to 1 minus sin 2x. But we want sin 2x only, right? From this, what is the value of sin 2x? Yes, sin 2x is equal to, when you transpose sin 2x that side and transpose t square this side, then it is going to be 1 minus t square. You got my point? So, t square is equal to 1 minus sin 2x. So, sin 2x is equal to 1 minus t square. Right? So, 1 minus t square can be substituted in the place of sin 2x. Now, you go with the substitution. That implies integral 0 to pi by 4. Here, limit should also be changed, right? When t is equal to sin x minus cos x is equal to 0. Then, what about the value of t? T is equal to sin 0 is 0 minus cos 0 is equal to 1. So, 0 minus 1 equal to minus 1. Therefore, the lower limit is supposed to be minus 1. What about the upper limit? And upper limit x is equal to pi by 4 should be substituted. X is equal to pi by 4. Then what about t? T is equal to sin pi by 4 minus cos pi by 4. So, sin pi by 4, cos pi by 4, both of them are same. So, therefore, which is going to be 0 because 1 by root 2 minus 1 by root 2. Therefore, the limits have been changed from 0 to pi by 4 to minus 1 to 0. Alright. Now, I am going to implement this here. That implies integral 0 to pi by 4 become minus 1 to 0. Right? Minus 1 to 0. Sin x plus cos x dx is going to be dt. dt divided by 9 plus 16 times sin 2x. Sin 2x is equal to 1 minus t square as we discussed, which is equal to integral minus 1 to 0 dt divided by 9 plus 16 into 1 is 16 minus 16 t square is equal to integral minus 1 to 0 dt divided by, how much is this? 9 plus 16 is 25 minus 16 t square. 25 minus 16 t square, I will try to get it in the standard form. What is the standard form there? Integral minus 1 to 0 dt divided by, I am taking 116 common out here. When you take 16, then it is going to be 25 by 16 minus t square. Right? So, 1 by 16 will be taken outside. Integral minus 1 to 0 dt divided by 25 by 16 is equal to 5 by 4 whole square minus t whole square. This is in which form basically? Integral dx divided by a square minus x square. Dx divided by a square minus x square is equal to 1 by 2a log mod a plus x by a minus x. Okay. 1 by 2a log mod 1 by 16 already there into 1 by 2a. A is equal to 5 by 4. So, 1 by 2a log mod a plus x means 5 by 4 plus t divided by a minus x 5 by 4 minus t. Between the limits minus 1 to 0. So, now you can simplify this. 1 by 16 into 2 ones and 2 2s are 4. This is 1 by 5 by 2 is nothing but 2 divided by 5 into log mod 5 by 4 plus t. Okay. 5 by 4 plus t is equal to, you can write it as 5 plus 4t divided by 5 minus 4t between the limits minus 1 to 0. so that you can substitute the limits. Before that, 2 1s and 2 8s are 16, 8 5s are 40. So 1 divided by 40 into log mod. See, when you substitute 0 here, 5 plus 4 zeros are 0. So 5 plus 0 divided by 5 minus 0. 5 by 5 is equal to log mod 1 minus, substituting minus 1 here. When you substitute minus 1, what do you get? Log mod 5 plus 4 into minus 1 is minus 4. So 5 minus 4 is equal to 1 divided by 5 minus of minus 4 is equal to plus 4. 5 plus 4 is equal to 9. Right? So which is equal to 1 divided by 40 into log, this is log 1 is equal to 0, or else you can write log a minus log b is equal to log a divided by b. Log a divided by b is going to be how much? 1 divided by 1 by 9. 1 by 1 by 9 is equal to 9. So log 9 is equal to log 3 square. Log 3 square is equal to 2 log 3. So 2 log 3 means 2 divided by 40 into log 3. 2 divided by 40 log 3 is going to be 1 divided by 20 log 3. Right? This way we can answer the problem easily. And one more problem is there. That is integral 0 to pi by 2 sin 2x tan inverse of sin x. How are you going to answer this kind of problems? See, I just left that problem there and I am going to answer the problem. I am going to change the pen. Right? So the problem given here is integral 0 to pi by 2 sin 2x into tan inverse of sin x. See, tan inverse of sin x cannot be simplified further. Right? So when it can be simplified further, what does that mean? It is understood that sin x should be substituted as t. Right? If sin x is equal to t, obviously cos x dx equal to dt. But where is that cos x dx? That we can figure out from here. So from this integral 0 to pi by 2 sin 2x formula is 2 sin x into cos x, right? 2 sin x into cos x into tan inverse of sin x into dx. Now the substitution is very much clear that let sin x is equal to t. When sin x is equal to t, derivative of sin x is cos x, dx is equal to dt. What does it mean? Cos x dx is right there is equal to dt. That can be substituted, but before that, since it is definite integral 0 pi by 2 limits are there, we have to change the limits accordingly, right? When x is equal to 0, then t is equal to what? Sin 0. Sin 0 is equal to 0. And similarly, when x is equal to pi by 2, then t is equal to sin pi by 2, which is equal to 1. Therefore, what are the new limits? New limits are 0 to 1. Integral 0 to 1, 2 into sin x, we have taken it as t. Cos x dx is obviously dt, and this is the tan inverse of t. So t into tan inverse of t into cos x dx is equal to dt. I think no more doubts. Alright, so this is in which form? 2 being a constant and t into tan inverse t dt. This is just like x tan inverse x dx. When you are applying by parts, because this is t is one function and tan inverse t is other function. It is an algebraic function as well as it is one inverse trigonometric function. So definitely we have to follow I-late rule. I means inverse trigonometric function. Inverse trigonometric function means tan inverse t comes first. Therefore, this tan inverse t is your u and t is v. I am going to simplify this. So, when you apply only integral, I am not writing everything again and again. I am applying integral. Therefore, u into integral of v. It means tan inverse t into integral t dt minus integral of integral t dt into d by dt of tan inverse t. Right? And when you simplify this, tan inverse t into integral t. What is integral t? Obviously t square by 2. That implies tan inverse t into t square divided by 2 minus integral t is nothing but t square divided by 2 into d by dt of tan inverse t is equal to 1 by 1 plus t square into dt. That implies this is t square by 2 tan inverse t minus this is 1 by 2 integral t square divided by 1 plus t square or t square plus 1, anything is fine. So 1 plus t square into dt. Right, this is 1 plus t square now. It is understood that add 1 and subtract 1. So 1 plus t square minus 1. Then it is going to be t square divided by 2 tan inverse t minus 1 by 2 into, see, 1 plus t square by 1 plus t square is equal to 1 minus 1 by 1 plus t square into dt. That implies this is t square by 2 into tan inverse t minus 1 by 2 into integral 1 dt is equal to t minus, what is this integral? This is going to be integral 1 by, like dt by 1 plus t square is a square plus x square or x square plus a square. That is 1 by a into tan inverse x by a means t divided by 1. So finally this is going to be t square by 2 tan inverse t minus 1 by 2 into t is equal to t by 2 minus into minus is plus 1 by 2 into tan inverse t 1 by 2 tan inverse t. Right? This is all about integral t into tan inverse t dt. But you have 2 also extra, right? So that finally I is equal to this 2 and here 2 and here 2 here 2 gets cancelled everything. So finally this is t square tan inverse t minus t plus half already cancelled tan inverse t between the limits. What are the limits here? 0 to 1. Between the limits 0 to 1. So then you can write this as between the limits 0 to 1. When you substitute 1 here, then that I is going to be 1 square is equal to 1 into tan inverse 1. Tan inverse 1 is equal to pi by 4. So it is going to be pi by 4 minus t. T is equal to 1 plus tan inverse 1. Tan inverse 1 is equal to pi by 4. Right? And then minus, when you substitute 0 here, 0 into anything is 0, minus 0, tan inverse 0 is also 0. So totally it is going to be 0. Finally the value of the integral is, this is pi by 4 minus 1 and this is pi by 4. So pi by 4 plus pi by 4 is equal to pi by 2 minus 1 is the value of, what is the given problem? Is the value of integral 0 to pi by 2 sin 2x into tan inverse of sin x. So this is about the very first paper. We discussed briefly. Very first paper is nothing but this is only one code, and when you change to another code, another set of paper, then some questions will be changed. That will be discussed in the next part of the video. Hope you understand. But this is one of the most important topics. We discussed about the weightage also, so that be very much careful about this. But you can answer the problems easily. Alright? Thank you.